Now we want to look at division with polynomials, and some of it will look very similar to what we did when we reduced rational expressions to lowest terms. Here I have this polynomial divided by 6x cubed. The instructions are divide. Now I'm going to use something similar to the distributive property when I divide by a monomial and simply write each term in the numerator over that denominator. So here I'm going to have 18x to the fourth over 6x cubed, and then 6x cubed over 6x cubed. So with this type of division, division by a monomial, what I do is divide each term in the numerator by that monomial. Then it's just a matter of simplifying each term individually. 12x to the fifth over 6x cubed will be 2x to the second when I divide coefficients and subtract exponents. Minus 18 divided by 6 is 3. X to the fourth over x cubed is x. And then 6x cubed over 6x cubed, that will be 1. So there is division of polynomials where I divide by a monomial, and the process looks very similar to what we did with the distributive property. Here I have x cubed minus y cubed divided by x minus y. Now I know that I can factor the difference of two cubes here, and one of the factors will be x minus y. So in this case, I can simply do my division by factoring the numerator and then dividing out common factors. So remember, I've memorized this formula for factoring the difference of two cubes, x minus y, x squared plus xy plus y squared. And that's all over x minus y. Divide out those common factors, and I've actually done division with polynomials by using my method of reducing to lowest terms from the previous section. So here's division by a monomial, here's division by a binomial where the numerator is factorable. Let's go to another problem where we divide by a binomial but the numerator isn't factorable. X squared minus 5x minus 7 divided by x plus 2. I can't use the method I used in the previous example because x plus 2 is not a factor of x squared minus 5x minus 7. So instead I'm going to use a form of long division similar to long division with whole numbers. We'll go through it once here, and then you can try some. I estimate by dividing x into x squared, that will be x, because x times x gives me x squared. Now I multiply x times 2 is 2x, and I'll write that under the term it's similar to. X times x is x squared. Next, I want to subtract this polynomial from this polynomial, so I change each of the signs and add, because subtraction is addition of the opposite. Negative 5x plus negative 2x is negative 7x. Positive x squared plus negative x squared is 0. Then I bring down the next term, minus 7, and I go through the process again. I divide x into negative 7x by asking what I can multiply x by to get negative 7x. And the answer is negative 7. Now I multiply negative 7 times positive 2, negative 14, and negative 7 times positive x, negative 7x. Now I want to subtract, and I do that by changing the signs and adding. Negative 7 plus 14 is going to be positive 7. There's no other terms to write down, so I write this as another 7 divided by x plus 2. So x squared minus 5x minus 7 divided by x plus 2 is x minus 7 plus 7 over x plus 2. And that division process looks like this, very similar to long division with whole numbers.